So this video is on engineering form and the SI prefixes. So both of these topics are related to standard form, so we'll see how a standard form can be used in both of these topics. So you are probably wondering, well, what is engineering form? And we'll come to the SI prefixes later. But what is engineering form? So on your calculator, so if you've got the Casio one or any scientific calculator, you should see a button that has ENG on it, and that means engineering form. So ENG, and that means engineering form. Okay, so what that means is it will convert like big numbers that you type in to standard form or close to standard form, where the power of 10 is a multiple of 3. So things like 10 cubed, 10 to the 6, 10 to the 9. So powers like that. But obviously we know from having looked at standard form that we can also have negative powers. So can we have negative multiples of 3? Of course we can. So we can have 10 to the minus 3, 10 to the minus 6, 10 to the minus 9, and so on. So if you haven't got a calculator to hand, can I suggest that you get one, because we're going to see an example of using the ENG button. So if we type into our calculator 54,000, so if we type that in and press equals, so that will bring up 54,000 as the answer. If we then press the ENG button, what that should do is it should pop out an answer which is 54 times 10 to the power of 3. So as we can see, it's brought out a number which is a multiple of 3 as the power. So I don't know, say that we had 62 million. So 62 and then 6 zeros. That's 3. And again, press equals on your calculator. That will store it as the answer. And then if we press the ENG button, it will reduce to 62 times 10 to the 6. And again, that power is a multiple of 3, 6, which is obviously a multiple of 3. So that's the general gist with engineering form. And then in the next part of the video, when we move on to the SI prefixes, we'll see how engineering form is useful. This is the second part of the video on engineering form and the SI prefixes. So in this part of the video, we're going to focus on the SI prefixes and see how it relates really to engineering form and how it relates to standard form. So on the right hand side, next to this red line, are some of the SI prefixes. We're just going to kind of like touch the surface with them. So as you can see, we've got tera, giga, mega, kilo, and then they go into negative powers, and you've got centi, milli, micro, nano, and pico. So as you can see, that for kilo example, that's 10 to the 3. So this is why it's linked to standard form, because we've got powers of 10 involved. And also interestingly, if you look from kilo upwards, the powers go up in multiples of 3, which is just like our engineering form that we did earlier. And obviously I said that it was linked. And this is where really the link is. And also in the negative powers, it goes minus 3, minus 6, minus 9, minus 12. They're all multiples of 3. And this is really why the engineering form is of importance. So we've got a question here, and it says, how many metres is 42 kilometres? So we'll use the prefix table in order to help us work this out. So we say 42, and we'll get rid of the kilo, because we know from the table that kilo is 10 cubed. So that's times 10 cubed. And now we've got rid of the kilo, so I'll just black that out. we're just left with metres. So it's 42 times 10 to the 3 metres. So that's how many metres, or if you like and prefer, it's 42,000. Because we know that 10 times 10 times 10 is 1,000. And that's really the point of having these prefixes, is that if we're writing down a calculation, we then don't have to write out 42,000 metres, and if we forget a zero, it messes up the calculation. We can just say, oh, it's 42 kilometres, because we know that we've got 3 zeros, so it's 10 cubed, and then 10 cubed is the kilo. Okay, so the next question, how many metres is 50 centimetres? So, again, we look at our table and we see that centi, oh, that's 10 to the minus 2. So we go 50, and now we can get rid of the centi part, so it'd be 10 to the minus 2, and then we're just left with the metre at the end, like before. So how many metres is 50 centimetres? It's 50 times 10 to the minus 2 metres, which if you wanted to write that as a decimal, we know that our decimal point is here, so it goes once and then twice. So we put a 0, put our decimal point, so we're left with is half a metre. And if we think about it, that makes sense because we know that 100 centimetres is 1 metre. Okay, and then another question, how many bytes, so B, of data is 4 gigabytes? So on your phone, if you go into the settings, say, your phone might say you have 4 gigabytes of storage left, and a byte is sort of one part of data, if you like, and then the gigabyte, so giga, is 10 to the 9. So we're getting an idea of how big like storage is in a phone, for instance. So it says here the multiplication factor, so it's 1 and then 9 zeros. So if we get this question here, how many bytes of data is 4 gigabytes? Well, it's like before. We put the 4. We know that giga is 10 to the 9, so it's times 10 to the 9. So then we can get rid of that, the giga part, and we're left with B. So it would be, how many bytes of data is 4 gigabytes? It would be 4 times 10 to the 9 bytes of data. So that would be this ridiculously long number, which would be 4, 0, 0, 0, then 0, 0, 0, and then finally 0, 0, 0. And really, going back to my previous point, this is why engineering form is useful, because we don't really want to write 4 with 9 zeros. We just want to put 4 times 10 to the 9 bytes. And then obviously, from our new knowledge of prefixes, we know that 10 to the 9 is a giga. So we can just say, oh, it's 4 gigabytes. And it just saves a lot of hassle in calculations and in like writing numbers down.